Hi guys, welcome to Code Bashers. So guys, in this particular video, I will be discussing the latest coding questions which were asked in Accenture exam. Okay, so as you all know that Accenture on-campus hiring is ongoing, and in this video, two coding questions I will be discussing. So make sure to watch this video till the end because same questions might repeat in your exam as well. Okay, and guys, before moving ahead, make sure to hit that like and subscribe button for this channel because for every company we are making preparation videos, and we will be starting from next week for TCS MQT preparation series also. So make sure to be present on this channel, and if you have any doubts you can write in the comment section or you can join this Telegram group. It's dedicated for 2026 batch students. So guys, now let's start this video. Make sure to hit that like and subscribe before moving ahead.
Okay, so guys, the first coding question is the magical number. Okay, I've again told you that this is a repeated question. So first question is, you are given a program to find the count of magical numbers from 1 to n. A magical number is defined by the following criteria. Convert each number in the range 1 to n to its binary representation, that is 0 1. Replace 0 with 1 and 1 with 2 in binary string. Calculate the sum of all digits in the modified string. If resultant number is odd, then consider it as a magical number. Okay. You will be given n as input. Find out all the magic number from 1 to n. So guys, there is a lot of story also that is written in the question, but the main point of this video is to tell you the gist of the question and tell you the solution for that. Okay. Now let me explain you clearly what is this question saying. So you will be given input as n. Okay, n here represents the range. So if it is given 4, so from the range 1 to 4 you will have to find all the magical numbers that are present. Okay, so if input is given as 4, so you have to consider the range from 1 to 4. If input was given to you as 5, then you have to consider the range of 1 to 5, and in that range you have to find the magical number. Okay, now what is a magical number? So simple definition is that, see, 4 was given, so we have a range of 1 was there, 1 is there, 2 is there, 3 is there, and 4 is there, all the numbers from 1 to 4. For every number, what we'll do, first of all we'll convert it into the binary form. Then after converting it into the binary form, okay, so if in the binary form there is 1 coming, so we will replace it by 2. If there is 0 coming, then we will replace it by 1. Okay, as it is given in the question only. If in the binary form, replace 0 with 1 and 1 with 2. Okay, so here binary form we have converted, and every 1 has become 2 and every 0 has become 1 now, and we have to do the sum of that. Okay, so yeah, so 2 it has become in binary form in the modified string, and 2 is the sum also, so it is even. So if the sum is even, then it is not a magical number. Otherwise, if it is odd, then it is a magical number. You will see. Next, coming 2. First of all, convert 2 into the binary form. The 2 will be in the binary form will be 1 0. Now convert this binary string into the modified form. What is the modified form? 1 will become 2 and 0 will become 1. Okay, so this is the modified form 2 1. Now what we have to do? We have to now calculate the sum of the digits. So 2 plus 1 gives us 3. Then 3 is odd, so therefore this is a magical number. I hope it is clear to you. Next number is 3. So 3 we can write as 1 and 1. Now you have to modify this binary form into the modified string, that will become 2 and 2 because 1 is replaced by 2. Then the sum of this 2 and 2 is 4. So now it has become even. So it is not a magical number. Similarly with 4, the binary representation is 100. If we have to make it a modified string, then it will become 211. Okay, and the sum of 211 is 4 only. 2 plus 1, and it is even. So it is not a magical number. So how many magical numbers are there from the range 1 to 4? Only one magical number is there, that is this one. So therefore our output is as 1. Okay, number of magical numbers from the range 1 to n. Next input is 5. Next input is 5. Okay, so you have to consider the range from 1 to 5 and how many magical numbers will be there. So 1 to 4 we have seen that there is one magical number. If I will consider the 5 also, let me just explain you. The binary form of 5 is 101. Okay, the modified string will become 2 1 2. The resultant sum will become 5. So it is odd. It is odd, so it is a magical number. Simple. So from 1 to 5, how many magical numbers are there? 2 is a magical number, 5 is a magical number. So total 2 magical numbers are there. Now let's just quickly move towards the approach, that okay sir, now how to approach this question. See, we have to for every number in the range we have to check whether the current number is a magical number or not. So how we will be check? How we will be checking? So let's suppose our current number is 5. It can be anything from range 1 to n. It can be anything, but let's suppose our current number is 5. First of all, converting this 5 into the binary form 100 101, and we know 0 will be replaced by 1 and 1 will be replaced by 2. How we will do it? So what we'll do, we will we know this is the binary form. We will now take this binary form bit by bit and do the operations. We are taking a variable sum as 0 also. We will be doing the operations bit by bit and we will be calculating the sum. If the sum is coming out to be odd, then it is a magical number. So starting from behind, so first we will take this bit. Okay, how we have to take this bit, I have already told in previous videos that how to take a set bit. So we will simply do the AND operation of this particular number. Okay, we will simply do the AND operation of this particular number with 1 0 0 and 1. This is the AND operation we are doing. Okay, so AND operation we have done. What is the output? Our output will be 0 0 1. This will be our output. So it means that this is a set bit. So once we have found this bit, okay, once we have found this bit, then we will simply replace it by 2 and we'll add it in the sum variable. So 2, add it in the sum variable, simple. Now the role of this particular one is done. We will simply do right shift. We will simply do this entire number right shift by 2, right shift by 1, right shift by 1 bit. Sorry, yeah, right shift by 1 bit we will do. Once we have done this right shift by 1 bit, so it will, the resultant number will become this. Now again we will do the AND operation of this particular number. Now since this last bit was 1, so therefore the AND with 1 gave us 1 only. But now since the last bit is 0, so AND operation with 1 will give us 0 only. So now we have got the 0, that is the last bit we have got. We know that 0 will be converted to 1, so we will simply add now 2 in this sum. We will add 1 also, so it will become 3. And the role of this is also done, so we'll do right shift by 1 here, right shift by 1 bit here. Now only one bit is remaining, so again we will again do this AND operation with this one. Since it is a 1, so we will be getting 1. Okay, 1 as an answer, and we know that 1 will be converted to 2, so therefore we will be adding 2 into this particular sum variable. That will become 5. Now this sum variable is over. Okay, so now this again we are doing right shift by 1, so this will become 0 after doing right shift by 1. So now this sum variable is 5. We know that 5 is an odd number, so therefore this will be a magical number. So for every number in the range 1 to n, we have to repeat this step for every number, and then in the end we have to return the count. I hope now the approach of this question is also clear to you. Now,
Okay, so guys, before moving ahead, I would like you to know that on our top mid page of Code Bashers, we have Accenture exam preparation material. So guys, any section that is coming in your Accenture exam, we have got that section covered here. So for all these sections, previously asked actual questions are there for the Accenture. So this particular material will contain common application MS Office MCQs, pseudo codes, network security MCQs, computer network MCQs, cloud fundamentals, coding questions which were previously asked in Accenture, SQL coding questions which are getting recently asked in Accenture, computer fundamental MCQs. For each and every section, we have at least 100 plus previously asked actual MCQs of that particular section. If I will show you the sample of, let's suppose, the Accenture coding PDF, you can see we have the proper question, we have the explanation of that question, and we have the correct answer, correct code for it. Similarly, in the SQL also, we have the proper question, we have the proper schema and the correct answer query for that particular question. Similarly, if I will open the common application MS cloud questions, so in that also we have the proper question, options and correct answer for it. So if you are preparing for Accenture exam, the best way is to by preparing by the previously asked questions only. So if you are interested, then the link of this material is in the description box, and there is a discount of 20% for first 100 students. Okay, so the link you can find in the description box. Now let's continue with the video.
so as I've told you earlier also, in Accenture what we do, we only have to implement the function, not the input and output things. Okay, so this is the function that will be given to you. Input will be the number that from which range you have to cover, starting from 1 till nth range. If our n is equivalent to 0, okay, if there is a range that is 0, so we will simply return 0, that there are 0 magical numbers present. Now there will be a variable called int count equivalent to 0. So this variable will store all the magical numbers from range 1 to n. Now what we'll be doing, we will be iterating over the loop. Okay, we will be iterating the loop, iterating the range from 1 to n, because for every number we have to check whether it is a magical number or not. If it is a magical number, we will add it to our count variable. For every number we have to check. Now we have taken the sum value, that will store that the current number sum after the modified string, what is the sum, is it odd or even. Now we have taken a dummy variable int j equivalent to I. Now all the operations we will perform on this particular j, we will have to now first convert to binary, then do the modification from 0 to 1, 1 to 2, and then add it to the sum variable. and as I have told you how to do it. Now this while loop, what we'll do, our j is the current number. So while j is greater than 0, what we'll do, we will try to find that whether the least significant bit, what is least significant bit? So if you will write 5 in binary form, so this is the least significant bit. It will check the least significant bit if it is 1 or 0. And how it will check whether it is 1 or 0? It will simply perform an AND operation with 1. I have told you why. So if the least significant bit is 1, then we are simply adding sum plus equivalent to 2, because we know that 1 will be converted into 2. This is a simple process. If the least significant bit is 0, then we are adding 1 to our sum variable, sum plus equivalent to 1. So if once this operation is done, then it means that the role of this particular set bit is done. Okay, role of this particular set bit is done. Now we will be doing j equivalent to right shift by 1. So I have told you, once we are doing this right shift operation by 1, so it will now become, resultant will become like this. Okay, the role of that bit is done, so it will be over, and we will continue doing this step till the current number becomes 0. Okay, now after this while loop is over, we have the sum variable. Okay, in that the sum is stored of the modified string. Now we will simply check that whether the sum is odd or even. So if it is odd, we will do count plus plus. This count variable will store the number of magical words. Okay, and in the end, once the for every number in the range we have done this entire step, we will simply return count from here in this loop. Now let's just quickly test it. Let's suppose 5, our answer should be 2, as I have told you that in from 1 to 5 there are total 2 magical numbers. In the range 1 to 4 there are total 1 magical number, and if we will try to pass 0 also, and we'll check whether it is coming as 0 or not. So 0 also will try to pass, and 0 also should give us the correct answer. For 0 it should be 0. Okay, and if we check for 1 only, so for 1 answer should be 0 also, because 1 is not a magical number, it is a even number. So yeah, output is 0. So this was the entire code, and it will be passing all the test cases that will be given to you. I hope the code, approach and question was clear to you. This was the first question. Okay, so now discussing the second question. What is the second question? It is find the sum of all the prime numbers till the given number n. Again guys, I am telling you that there will be a long story written in the question, but here the main motive is to tell you the question, the main gist of the question. So find the sum of all the prime numbers till the given number n. You will be given an input n, okay, 10. From the range 1 to 10, you will have to return the sum of all the prime numbers. So from the range 1 to 10, the prime numbers are 2, 3, 5 and 7, and what is their sum? Their sum is 17. So we are simply returning 17 from this particular function. Okay, this was the gist of the question that was asked today. I hope the question is clear to you. Simply n will be given to you. From 1 to n, you have to find all the prime numbers, and you will have to give their sum as the output of that function. Now let's just quickly see how to check whether a number is prime or not. Okay, so first we need to see how to check whether the current number is prime or not. Okay, because from the range 1 to n, we have to check every number whether it is a prime or not. So how to check whether a number is prime or not? Let's just see. Let's just take an example that our current number is 36. We have to check whether 36 is a prime number or not. What we will do, there is a simple step for doing it. First of all, what is a prime number? So prime number is a number which is only divisible by itself or by 1. Okay, which is only divisible by itself or by 1. Again, I'm telling you, prime number is the number which is only divisible by 1 or by itself. If it is divisible by other numbers like 2, 3, 6, 5, something else, then that number will not be a prime number. I hope this is clear to you. Now, how to check whether this 36 is a prime number or not? We will simply run a loop from I equivalent to 2 till I less than equivalent to square root of 36. Now guys, you will tell, sir, why we are running the loop till square root of 36. Understanding the concept is important. See, first of all, let's just quickly calculate the square root of 36. So SQRT of 36 is nothing but 6. So I am saying that you have to run the loop from I equivalent to 2 till square root of 36, that is 6 only. Sir, why like this? So the answer is simple. See, if a number is greater than the square root of 36, let's suppose there is a number called 9. So is 36 divisible by 9? Answer is yes. So sir, we are not checking whether it is divisible by 9 or not, because we are running the loop till square root of 36 only. Why we are doing it like this? Because see, if 36, we know that 36 is divisible by 9, but 9 is divisible by 3. So this 3 is already coming in this particular loop. Again I'm telling you, this 3, 9 is divisible by 3, and this 3 is already coming in this loop. Again, sir, okay, 9 I have clear. Now 12, let's just see 12 also. So 36 is divisible by 12. Okay, now, so we are not checking whether for the 12, but see 12 is also divisible by 2. So it means that, see, all the numbers for which a number can be divisible by are covered between I equivalent to 2 till I equal to 6, because if a number is greater than the square root of that number, then that particular number is already divisible by the numbers which are in the range lying from I equivalent to 2 till I less than square root of that number. I hope that now I have made my point that why I will be running the loop from I equal to 2 till the square root of that number. Okay, if in this range, okay, we are checking with this 36. If in this range, if the number is divisible by, okay, if the main number is divisible by any number in this range, then it means it is not a prime number. And if this number in this particular range is not divisible by any number, then it is a prime number. Simple as that. For every number in the range from 1 to n, we have to check whether it is a prime number or not. If it is a prime number, we will have to add it into a sum variable, and we will return the sum of all the prime numbers lying in that range. So the time complexity of this particular question will be n, because n into sqrt of n. This will be the time complexity of this particular question. Why n? Because we are range is 1 to n, and for every number we have to run a loop till square root of n. So you will be saying, sir, there is a one better approach also, that is sieve of Eratosthenes. Okay, I know that is difficult to pronounce, but that is a optimal way for doing this particular question. But see, there is not much constraints in Accenture regarding the time complexity. Okay, I'm not saying you should not write optimized code. You should always write optimized code. But again, the main aim of this video is to make you understand the concept so that it can reach to the wider audience. If I try to explain the sieve method for this question, then lot of you people will becoming confused. Okay, so just try to follow this method. I know it is not the most optimal way, but many it is a very easy method, and the time complexity is also not very high. So let's just now quickly move towards the coding part of this question, because
Okay, so guys, before moving ahead, I would like you to know that on our top mid page of Code Bashers, we have Accenture exam preparation material. So guys, any section that is coming in your Accenture exam, we have got that section covered here. So for all these sections, previously asked actual questions are there for the Accenture. So this particular material will contain common application MS Office MCQs, pseudo codes, network security MCQs, computer network MCQs, cloud fundamentals, coding questions which were previously asked in Accenture, SQL coding questions which are getting recently asked in Accenture, computer fundamental MCQs. For each and every section, we have at least 100 plus previously asked actual MCQs of that particular section. If I will show you the sample of, let's suppose, the Accenture coding PDF, you can see we have the proper question, we have the explanation of that question, and we have the correct answer, correct code for it. Similarly, in the SQL also, we have the proper question, we have the proper schema and the correct answer query for that particular question. Similarly, if I will open the common application MS cloud questions, so in that also we have the proper question, options and correct answer for it. So if you are preparing for Accenture exam, the best way is to by preparing by the previously asked questions only. So if you are interested, then the link of this material is in the description box, and there is a discount of 20% for first 100 students. Okay, so the link you can find in the description box. Now let's continue with the video.
so again in the Accenture only you have to implement the function. So you will be getting input in this function as n. This n is a range. This n is the range. From 1 to n you will have to find all the prime numbers, and you will have to calculate the sum of all the prime numbers and return it. So if our n is double equivalent to 0, so range from 1 to 0, nothing. From range 1 to 1, 1 is neither prime nor composite, we know, so we are returning 0. So if the range is 1 only, so only 1 can be considered here. Now we are taking a variable sum equivalent to 0, initializing with 0, okay, because this variable is used. Why it will be used? It will be used to store the sum of all the prime numbers. Now we will be finding all the prime numbers from the range 1 to n. Okay, for int I equivalent to 2, I less than equivalent to n. Why 2? Because see, 1 I have told you it is not either prime nor composite. So therefore, from the range 2 to n, we have to find all the prime numbers, sum of all the prime numbers. Inside the loop, we are taking this variable bool is prime equivalent to true. Okay, we are considering that the current number is true. it will only become that the current number is not prime once it is divisible by some other number. So for checking that divisibility, we are again making a for loop inside it. So this is the for loop, this one that I have discussed. For every number we have to run like this. Starting from I equivalent to 2, that is j I am taking in this case because I already have taken outside. So starting from range j equivalent to 2, j less than equivalent to square root of I, because our current number is now I. Okay, current number is I, j plus plus. Now for every number in this range, we will be checking whether our current number is divisible by any of these numbers in the range or not. That is, I mod j is double equivalent to 0. It means it is divisible by numbers present in this particular range. So if this condition is successful, it means that this is not a prime number, because either it is divisible by 2, 3, 4, 5, 6, any number it can be divisible by. So therefore, if I mod j double equivalent to 0, it means that it is not a prime number. So we are making is prime equivalent to false in this particular for this particular number. We are breaking from this loop, and after this loop we are checking whether whether this current number is prime or not. If it is a prime number, then we are simply adding that number to the sum variable. And in the end, once for all numbers we have checked whether it is a prime number or not, we are simply returning the sum from here. Let's just quickly see the with the help of example. So 10, let's just put it. So from 1 to 10, the 17 should be the answer, because 2, 3, 5, 7 are the inputs. Okay. And if I try to pass any custom, any other also, like suppose 15 should I pass. So in between 15, 11 also will be added, 13 also will be added. So 24, 31 should be the answer. 41, sorry. Yeah, 41 is the answer. That is from 1 to 15. The prime number sum is 41. 2, 3, 5, 7, 11 and 13.